Hello and welcome back. I hope you have successfully installed all the required dependencies on your computer. Now let's discuss what we are going to build with the Polygon Edge here. You know that blockchain is built with the peer-to-peer decentralized network of nodes, and these nodes are nothing but the computer machines. So now in order to run the Polygon Edge, we will have to run more than one node, right? But we have only one single machine right now. So as of now, what we will do is, we will run all the nodes on a single machine using different ports. So we will set up the Polygon Edge network with the IBFT consensus protocol, which has a proof of authority by default. We will see how to migrate from proof of authority to proof of stake later in this course. We will set up the blockchain network with 4 nodes, out of which all of them will be the validator nodes as of now. These 4 nodes will run on the same machine on different ports. The second thing to consider here is that, as you know, each and every node in the network has a complete copy of blockchain. So now there will be a total of 4 blockchain folders on our computer that will belong to these 4 nodes respectively. So why are we setting up exactly 4 nodes? Why can't just 1 or more than 4? Well, there is no minimum amount to the number of nodes in the cluster, which means cluster with only one validator node are also possible. Keep in mind that with the single node cluster, there is no crash tolerance or no IBFT guarantee. The minimum recommended number of nodes for achieving the BFT guarantee is 4. Since in the 4 node cluster, the failure of one node can be tolerated with the remaining 3 functioning normally. Here we are talking about the cluster. A computer cluster is a set of computers that work together so that they can be viewed as a single system, that's it. So the complete steps for setting up successful edge networks are: the first one is to initialize the data directories and validator keys for each of these 4 nodes. These data directories will be empty as of now, but later it will hold the complete blockchain copies. The validator keys on the other hand are important to generate the genesis block with the initial set of validators. The genesis block is the first block that is created on the blockchain. The second one is to create a connection string for defining a boot node. Now let me explain you what the boot node is. In a decentralized peer-to-peer world, there is no single centralized server or node to connect. In the case of centralized system, it is very easy to find which node to connect to for an outsider node willing to connect to the network. But in case of a decentralized network, each node works independently and also is not connected with all the other nodes in the network. That's where the boot node comes into picture. For a node to successfully establish connectivity in the decentralized network, it must know which boot node server to connect to in order to get the information about the all remaining nodes on the network. Boot node is not a special instance of Polygon Edge node. Every Polygon Edge node can serve as a boot node, but every Polygon Edge node needs to have a set of boot nodes specified, which will be contacted to provide the information on how to connect with all remaining nodes in the network. Now the third step is to generate a genesis file with all 4 nodes as a validator and 2 nodes as a boot nodes. Now while generating the genesis file, you will probably want to set up the blockchain network with some addresses having pre-mined balances. To achieve this, we can use the pre-mine flag per the address that you want to be initialized with the certain balance on the blockchain. We will see how to do this when we set up the networks. And lastly, the fourth step is to run all the nodes. Because we are attempting to run Polygon Edge network consisting of 4 nodes on the same machine, we need to take care to avoid port conflicts. While discussing the architecture of the Polygon Edge, we have discussed 3 terms: libp2p, gRPC and JSON RPC. So while running the nodes on Edge, each node will consist of these 3 servers as a whole. To avoid the port conflicts and recognize which port belongs to which node, we can use some structured port numbers like, for the first node, its gRPC server will run on port 10,000 its libp2p server will run on port 10001 and JSON RPC will run on 10002. Similarly, for the second node, the gRPC server will run on port 20000, libp2p server will run on port 20001, and JSON RPC will run on 20002, and so on. These three servers can be started simultaneously using the configuration file. We will see how to do that in later part of this course. For now, I think you have got the overall idea of what we are going to build and some understanding of terminologies like node, boot node, validator keys, data directory, and the process of setting up the network. Now in the next lesson, let's set up a network on our local machine. See you in the next lesson.